Sorry about that. We were almost 2 minutes in, and then I had some storage issues on my phone. But I was just talking a little bit about where I was going with, I guess, applications and moving from number theory again over to applications through calculus, through other things, and the zero approaching infinite duality or relationship in terms of an undetermined ratio or an indefinite ratio. So again, as we know, anything over zero is going to be undefined, and what that has to do with a limit approaching an asymptote, obviously. So, going back to the idea of a circle. So picture, this is what I jotted down. So picture we have, say, a hexagon or a polygon, right? It's not quite a circle yet because its sides are not anywhere close to approaching infinite. Or let's just say it's nowhere close to infinite. So it's not approaching infinite, right? So each side, picture each side to be a, say, asymptote. So we get this idea of a ray of light approaching an asymptote within the circle and then shifting as each, and this is complicated, as each asymptote shifts to form a circle, that ray of light is bending and bending and bending and bending and bending to make room for each asymptote within a circle. And I believe, and I haven't looked into this, I believe this is some kind of proof for the fact that light refracts within a prism, which a prism is simply a three-dimensional, well, it's a three-dimensional, say, polygon, or it's a jagged gon. I forget what the term is. It's a three-dimensional rock, okay? Crystal. So, but we have all these asymptotes that have light approaching it and bending along it in order to approach it, but never can. And I'm not sure where I'm going with this at this point, but relating back to a circle having approaching infinite sides and simultaneously zero sides, but for now I'm focusing on the approaching infinite sides, and I need a sip of coffee. We're going to say that, I really should take out my notes for this, but we're going to quickly say that equivalency and application for this theorem, if it is a theorem, which I'm not sure it is, because listen, these are just lectures. There's nothing scientific about this. We're just talking. So what I'm actually trying to do is get words out into my head and on record so that there is a record of these lectures. But and this could make no sense. It could make some sense, but what I'm trying to do is find relevancy and application so that these ideas that I'm coming up with have some application in the end. And listen, I'm not a physicist, I'm not an engineer, I'm not a scientist at all. I am just literally a thinker who understands math and knows the power of theorization and how a good theory can lead to good technology. Breakthrough technology, in fact. So, I mean, obviously, I do dare great things, as Roosevelt said, one has to do. I did look up. I used Google to look up whether it was a unique thought that a circle has both zero and approaching infinite sides. And guess what? That appears to be an original idea. So, hey, pat on the back for me. Kudos for coming up with that one. Whether or not that's provable or relevant or significant in any way, who knows? But it looks as though that might be a unique or original idea in and of itself, perhaps. Or I'm completely out to lunch, which is a definite possibility. So, great theories have great consequences in life, in the world. And I want to go somewhere with this idea of, I'm really the circle is just a metaphor, But what I'm doing is I'm approaching an idea of zero and approaching infinite equivalency, relationships, undeterminate ratios, the undefined ratios. I was always fascinated with that because the calculus is always about the limits, the limits, limits, limits. Never approaching. Understood. I mean, that is pure physics 101. We have the ray of light never reaching its potential, and that is a limit. That is calculus, right? That is a speed limit of the galaxy, of even what we could call the universe. So I am interested in this. And when Einstein developed relativity, both theories, special and general, or whatever, the like once again, applications throughout the rest of the 20th century and beyond were insane, like absolutely insane. So this is an example of how a good mathematical foundation on a good theory can lead to crazy developments in the world. And I'm not ambitious in terms of anything technological, not really. I want to use my brain power and my mind to do something in math. And sure, if there's an outcome, there's an outcome, but that's just where I'm going with this. And people won't understand why you're interested in pure math if there doesn't appear to be some kind of application potential. But my interest and my phone is flashing right now for some reason. Maybe it's low on batteries. I don't know. But my it seems to be going. I've always been a pure math guy, and that is simply it. But at the same time, alongside that, listen, I'm still a real person, so I do want some kind of recognition or whatever. So I'm kind of simultaneously looking at the pure math side and the application side. So listen, we're on lecture 5, or I think it's lecture 6 or 5. It's lecture 5, I think, or 6. But we're going to go forward and look at these ideas in a bit more detail. And the lecture series will end at number 10, as I said, at which point there's going to be a lot of scribbling on my part, perhaps frantically looking for people to help me. But, so we have 2 minutes left. And normally I'd say, are there any questions? But can an asymptote shift alongside with its function is the question that I'm currently looking at. Because if an asymptote is a side on a polygon, and again, a circle is an infinitely sided polygon, then that question does seem a bit relevant. So can an asymptote shift along with its function on a two-dimensional plane, an xy plane? Can it? Can an asymptote shift? Can an asymptote shift? Can an asymptote shift and rotate, therefore smoothing out a circle, sphere, whatever? Can we have a shifting asymptote? Meaning a shifting, I guess, unexplained or undefined ratio, or an indeterminate or undefined product or result on a ratio where 0 is the denominator. So you see where my mind is going? I'm starting at a basic level, looking for basic stuff without influence and applying raw creativity and coming up with something unique, just like John Nash did, right, with game theory. So that's where I'm going. We have about 50 seconds left, and I will sip my coffee. We're going to wrap up the 10 lecture series, and that'll be that. And it's been fun so far, but we still have about 4 more lectures, each being 10 minutes, and I've enjoyed it. There's going to be a lot of note taking at the end of this, and a lot of scribbling, and a lot of collaboration, hopefully. But this was a good start, and I moved beyond just the theory, just the math, and just the calculative approach, and now I'm talking about a vision for something It could be useful. And with that, I'm going to let you go, and we'll see you tomorrow. Have a great afternoon. Bye.